Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on July 31st, 2025, so just about 4 days ago. This paper introduces a new model that gets around the need for a VAE, that's a variational autoencoder, which is a component many models use to first compress images into a smaller, latent space. The paper is titled PixNerd, Pixel Neural Field Diffusion, and as we'll see, the results are really impressive. This new approach avoids the accumulated errors that can come from that two-stage 5AE process, achieving a competitive 2.15 FID score on ImageNet without one. Also, the authors shared their work on GitHub, and it's a great repo. You'll find the full source code, pre-trained model checkpoints, and clear instructions for both training and inference. They've even provided an online demo you can try out, which is always fantastic to see. On Hugging Face, you'll find the XL and XXL model weights available for download, along with the demo space to try the text-to-image model out for yourself. Alright, so the first figure here really visualizes their core idea. On the left, it contrasts their single-stage large patch model with older methods, like latent diffusion, which needs that VAE, and other pixel models that use complex, multi-stage pipelines. Their approach is much simpler. Then on the right, we see how it works. The main diffusion transformer predicts the weights for what they call a neural field. This neural field, basically a small network for each image patch, then models the fine details, replacing a final, complex decoding step. And this next figure shows the results of that architecture. These are sample images from the PixNerd XL16 model at both 256 by 256 and 512 by 512 resolution. They look fantastic, and were generated using a CFG value of 3.5, which is a setting that controls how closely the model sticks to the image category. Building on those class conditional images, this next figure showcases the model's text-to-image capabilities. And you can see it handles a huge variety of styles and very detailed prompts, from a mechanical octopus to a surreal landscape with a waterfall flowing upward. What's really impressive is that PixNerd generates these high-quality images using a large patch size of 16. Using larger patches is more efficient, but often makes it harder to capture fine details, so this is a great result. They generated these in just 25 steps using the Atom second solver, which is the specific mathematical method used to create the image. Now, one of the coolest features they demonstrate is training-free arbitrary resolution generation. This figure shows how PixNerd can create images at different sizes and aspect ratios, like the cabin scene going from square to wide, all without any retraining. They achieve this by simply adjusting the internal coordinates of the neural field for each patch. This means the number of tokens stays constant, making the model incredibly flexible and efficient. This table then details that efficiency, breaking down the resource consumption. During inference, which is the process of actually generating an image, you can see PixNerd is much faster. It takes just 0.65 seconds to create an image, while other pixel-based models like PixelFlow need over 10 seconds. This makes it a really practical and efficient alternative. And this table really puts that performance into perspective, comparing different models on the ImageNet 256 by 256 benchmark. The key metric is FID, or Fréchet Inception Distance, which measures how realistic the generated images are. A lower score is better. As you can see, PixNerd XL16 achieves an FID of 2.15. This is highly competitive with top latent models, and much better than other direct pixel space models. It also gets a strong SFID score, which specifically measures spatial quality, confirming the images have good structure. So, to wrap things up, PixNerd presents a really elegant solution for high-fidelity image generation. By using a neural field to model details within image patches, it successfully avoids the need for a VAE, achieving top-tier results with much greater efficiency. That's it for this episode.